Hi guys, a video on adding and subtracting surds, which is 3B from your textbook. So we can add and subtract surds, and they add and subtract much like we can add and subtract algebraic terms. So we look for like terms in algebra, and we look for like surds when we're adding and subtracting surds. So the rules are the same. You add the coefficients and you keep the surd the same, or you add or subtract the coefficients and you keep the surd the same. So looking at this first example here, okay, if you could imagine this is 2 root 3 plus 4 root 3, that's how you say it. It could, in algebraic terms, it would be 2 times A, or 2 groups of A plus 4 groups of A. Now, we all know that. We've well practiced in this sort of thing, so that would be 6 groups of A. Okay, so these are like surds, they're both root 3. Okay, so we can add the coefficients, which is 6, and we keep the surd the same, so that's root 3. Okay, and that's your answer. Okay, it's as simple as that. So we're looking for terms that have the same surd in them. Okay, so this second example B here, we've got some root 6's, okay, and we've also got some root 2's. Alright, so we can add the root 6's together. So in this case we've got positive 4 minus 3, and that's going to be 1, okay, and that's one group of root 6. Alright, now the second one here, we've got root 2, 3 root 2's plus 2 root 2's, and we have 5 root 2's, okay. So again, these are like algebraic terms. If this was an A, if this was an A and this was a B, okay, this could not be simplified any further. All right, and it's the same with this. Now, the only thing we might do with this is you wouldn't say 1A, you just say A. Okay, so this is actually equal to root 6 plus 5 root 2. Okay, and that's as simple as you can go. Now, I'm going to move on to slightly trickier ones down here. Okay, now this is simplifying again. So we're looking for like surds. Now, just looking at this, they look completely different surds. There's different numbers under the root signs. So you might think that, no, we can't do anything now. It's not the case, as if you have a look back to our first section, so 3A, you can actually simplify this root 8 here. Okay, so we'll do that first, okay, because that'll actually create a like surd for us. So root 8, as you know, 8 can be divided into 4 and 2. Okay, and 4 just happens to be a square number. So I'm going to do all these steps to start with. Okay, this is what we were doing in the last one. Okay, so square root of 4 times 2 can be broken down to the square root of 4 times the square root of 2. Okay, the square root of 4 is 2, and we still have that root 2, which can't be simplified. Okay, so that's another way of writing root 8. And if you put that in your calculator and press enter, so if you put root 8 in your calculator and press enter, you'll get 2 root 2. That's the answer it'll spit out. Okay, which is good because now if I bring this down, okay, like this, I've now got a like surd. I've got some root 2. So again, I keep my square root and I plus take away or add my coefficients. In this case, it's take away 5, take away 2 is 3, and my surd is root 2. Okay, so that's how you simplify a surd. Okay, so this second question here, again, we haven't got any immediate obvious things we can simplify or collect together, but a good clue is this root 5 at the front here. Okay, so like in this question, which is adding and subtracting, they probably wouldn't put this question in unless you could actually add and subtract something. So root 5 is a hint to you as to what one of the factors or one of the surds might be, and just showing you, let's have a look at this 3 root 20. 2 root 5 is as simple as it goes. Root 5 doesn't have any 5 doesn't have any factors. It's a prime number, so can't break that down, but 20 is a different story. Okay, so negative 3 root 20. Now, if you think about the factors of 20, it's 10 and 2. Neither 10 nor 2 are square numbers, but another factor pair is 4 and 5. So, and 5 is actually the surd you're looking for. So 4 times 5 is going to be a really good pair of numbers to work with. I'll do this one first, and then we'll go on to the second one, and we'll do it down the page. So negative 3 square root of 4 times the square root of 5. Okay, now the square root of 4 is 2. Okay, so it's going to be negative 3 times 2 times the square root of 5. Okay, negative 3 times 2 is negative 6, square root of 5. Alright, so that's as simple as it goes. Okay, so the number out the front, once you've square rooted that number from the brackets, you have to times it by the one in front. Okay, because all these things, this actually means to times that. So that's actually negative 3 times root 20. Okay, so once a number comes out of the square root, you have to times it by the front number. Okay, same with this one. This one's not quite as obvious. 45. Well, if we're looking for a factor of 5, 5 times 9 is 45. 9 is a good number because it's a square number. So we're going to do 6 square root of 9 times 5. Okay, so let's do another step. Square root of 9 times the square root of 5. Okay, the square root of 9 is 3 and root 5. Okay, I'm taking out the times there. Hopefully you can see that if you have a number followed by a bracket or a surd, it's actually meaning to times, okay? Yeah, okay, so 6 times 3 is 18, square root 5. Okay, so I'm going to bring my original first term down because that's actually just stays as it is. Alright, 2 root 5 minus 6 root 5 plus 18 root 5. Okay, it's going to be something root 5. We just have to add and subtract all these things. So if you think about 2, take away 6, negative 4, plus 18 is 14. Okay, 14 root 5. Okay, so that is your simplest form answer for that example. Okay, have a go at some questions, and I'll see you in class.